Students, let's revise all the formulas of chapter 2, electric potential and capacitance, right? First, tell me what is potential difference. In your class 10th also you have learned this one, and I have already told you. What is the formula for potential difference V? Students, potential difference is equal to work done by charge. Yes or no? Potential difference is equal to work done by charge. Do you remember the formula? V is equal to W by Q. What is W? Work done, right? What is V, students? Potential. What is Q? Charge. Are you listening all?
Yes, sir.
Then number 2, we have also found out electric potential due to a point charge Q at a distance R from it, right? So write electric potential due to a point charge. Electric potential due to a point charge. I will share the notes in the description box, as well as I will share the soft copy also, right? Electric potential due to a point charge Q at a distance R from it. At a distance R from it, right? So that is how much, student? What is the formula? 1 by 4 pi epsilon naught. 4 pi epsilon. What is Q by R? Do you remember or forgot? Students, understood now?
Yes, sir.
There are number of charges. Electric potential at a point due to n number of point charges. There are many point charges. We want to find one, right? So we can write, let's write electric potential, right? Electric potential at a point. Electric potential at a point due to n point charges, right? Due to n number of point charges. So what we have to do? We have to algebraically add all, right? N point charges. We have done examples on charges placed at 2 corners, 3 corners of a triangle, 4 corners of a square. Yes or no?
Yes, sir.
So that is V is equal to, what is the formula for that? 1 by 4 pi epsilon naught. We have to sum all the quantities. Qi, I means number of charges, Ri means position vector of every charge, and I varies from first charge. I is equal to 1 to n, right? This is the formula. You have already done the examples of 3 charges on a triangle, on a square, right? Then we have learnt about electric dipole, right? We have learnt about electric dipole, equatorial line and axial line. Do you remember? Electric potential, next, right? Electric potential at a point. Electric potential at a point due to a dipole. Due to a dipole, correct? That is V is equal to 1 by 4 pi epsilon naught P cos theta. You know, if it is axial line, then theta is equal to almost 0 degree, right? If it is equatorial line, then what is theta, students? 90 degree. Are you getting or not? And P cos theta, if I'll take the unit vector P dot R divided by RQ, right? Understood or not, students? P is electric dipole. What is the unit of Q, students? What is the unit of charge? Students? And R here used in meter. That is in distance in meter, right? In meter. Unit is meter. That is the unit of distance, right? What is the unit of work? Joule, right?
Joule.
And what is the unit of V? Voltage. What is the unit of potential difference? V, that is voltage, right? Yes or
Yes,
no?
sir.
Potential difference is V. I will ask everyone all the formulas tomorrow, right? V, that is unit is in volt. Correct? Understood all, students? You remember these formulas? Remember or not?
Yes, sir.
Next, also I had told you the relation between electric field and potential, right? Relation between electric field and potential. Do you remember? What is the formula? Relation between electric field and potential. Electric field and potential. What is the formula, students? Already I have derived. E is equal to minus dV by dr. If you will differentiate electric potential, you will get what? Electric field, right? Let the electric field varies along x, y, and z. So you can individually you have to see how the electric field varies. So Ex is equal to minus dV by dx. How it varies along x, right? Electric field along y means how the electric field varies along y, right? Ez, what is the electric field along dV by dz? Understood or not, students? Remember?
Yes.
Electric field between two parallel conductors also we have derived. Electric field, right? Electric field between two parallel conductors. Electric field between two parallel conductors, right? E is equal to how much? V by D, correct? E is equal to V by D. T is the distance between the two parallel conductors. Getting, students? And how can you find that? How can you find if you know E is equal to minus dV by dr, right? So you can write dV is equal to minus EdR. Can you write or not? And if you want to find potential, then I can integrate dV, right? That is equal to minus E dot dr, correct? Distance is, you can take any negative, any one negative, right? Distance is infinity to R. From what distance to what distance I'm bringing. Understood all, student? Understood or not? Students, are you getting? Students, are you getting? E dot dr. So dV is equal to E dot dr, right? Next, also I had told you one formula about, electric potential energy of a system of 2-point charges. Students, let there is a charge Q1. There is another charge Q1 and Q2. Let the position vector between them is R12, right? So can we find electric potential energy, right? Electric potential energy of 2-point charges. Electric potential energy of 2-point charges, right? That is U is equal to how much? 1 by 4 pi epsilon naught Q1 Q2 by R12. Do you remember this formula or not? U is electric potential energy, right? Getting, students? Next, electric potential energy due to a system of n-point charges, right? Next, right? Electric potential energy, right? Electric potential energy of a system of n-point charges. Of a system of n-point charges. Correct? That is equal to, we have to sum all the potentials due to every individual charges, right? 1 by, then how many pairs? We have to add all pairs, right? It may be 3, it may be 4. All pairs. That is Qi, Qk, Jq, Qj, Qk, position vector of Rjk. Are you getting? You see, we have done the examples: potential energy due to 3 charge system on a triangle and potential energy due to 4 charges system on a square also. Are you getting all? Students?
Yes, sir.
Next, another formula, semi potential energy of an electric dipole in a uniform electric field. Dipole, PE cos theta. Do you remember? See your copies. We are revising all the formulas of chapter 2. Potential energy of an electric dipole, potential energy of an electric dipole. Take a snapshot of attendance and say me, anyone. Potential energy of an electric dipole, right? In a uniform electric field. In a uniform electric field, right? That is U is equal to minus PE cos theta 2 minus cos theta 1. Means the angle is varying from which angle to which angle, initial position and final position. Yes or no? Initially, how much angle you have made with the electric field and the dipole, then from which angle to which angle, right? Getting on our students.
Yes, sir.
Then what is the unit of here? Charges are in coulomb, right? Distance is in meter and energy in joule. Or sometimes energy may be given in electron volt, right? You know electron volt, EV. Student, V is equal to W by Q, right? And W is equal to VQ. V means volt, Q means charge. If this charge is charge of one electron, let the charge is this Q is charge on one electron. Charge on one electron, one electronic charge. Then work is going to be how much? 1.6 into 10 to the power minus 19 coulomb into joule, right? And joule into coulomb is volt. That can also be written as 1 EV. Or if I'll put the value of, if I want to convert EV into joule, then you have to do like this, right? Understood all students? Then 1 EV means how much coulomb? Means 1.6 into 10 to the minus 19 coulomb, right? 1 mega electron volt means, students, how much? 1.6 into 10 to the minus 19 into 10 to the 6 mega, that is 1.6 into 10 to the power minus 13 joule coulomb, right? Understood or not, students? Joule, that is joule, right? All understood? All understood, na, students? Then student will go to capacitance, right? Capacitance for a solid spherical conductor. What is the formula? Capacitance of a spherical conductor, right? Next, we have learned about capacitance of a spherical conductors. This is number 11, right? Next formula of this chapter, number 11, that is capacitance of a spherical conductor, right? Capacitance of a spherical conductor. Anyone send me the attendance? Send me, na? Capacitance of a spherical conductor of radius r. That is C is equal to 4 pi epsilon naught into r. Right? What is r here, student? Radius of the sphere, right? And you also know capacitance is equal to how much? Q is equal to CV, right? You know, Q charge is equal to capacitance into potential, right? So you can write capacitance is equal to, right? This is Q is equal to CV. Means capacitance is equal to charge by potential. Capacitance is equal to charge by potential. Understood, students? Charge is in coulomb, potential is in volt, and unit of capacitance is what? Farad. Yes or no? Charge is in coulomb, potential is in volt. Are you getting all? Students getting all, na? Next, formula number 13 of this chapter, right? Capacitance of a parallel plate capacitor, right? capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor, right? That is C is equal to epsilon naught A by D. No? Parallel plate, area of the plates A, and distance between separation between the two plates is D. Correct, students? Let we're having two plates, correct? We're having two plates. In one plate, the charge is Q1, the another plate, the charge is Q2. Then potential difference between the two plates will be how much? So right, next question, next formula, right? Potential difference, right? Potential difference between the two plates. Potential difference between the two plates of a capacitor. Potential difference between two plates of a capacitor having charges Q1 and Q2. That is V is equal to how much? Q1 minus Q2 by 2C. Next 15. Capacitance of a spherical capacitor. So in spherical capacitor means there is some inner radius, there is some outer radius, right? In that case, what will be the formula, right? Next, right? Capacitance of a spherical capacitor. Follow spherical capacitor. That is equal to student formula, right? C is equal to 4 pi epsilon naught AB by B minus A. Outer radius minus inner radius, right? Keep in box the formula. So here A is inner radius and B is outer radius. B is outer radius, right? Then student comes capacitance of a cylindrical capacitor, right? Capacitance of a cylindrical capacitor, correct? That is equal to the formula you write, then you'll know the notations. 2 pi epsilon naught L, length of the cylinder, log base E B by A. If base E you want to convert to base 10, right? Then you have to multiply how much? 2.303. Do you know that? 2 pi epsilon naught L by 2.303 multiply log base 10 into B by A, right? So A is inner radius and B is outer radius of a coaxial cylinder, right? And L is the length of the capacitor. So you can write here A and B are the radiuses, it's radii of inner and outer, coaxial cylinders, and L is the length of the capacitor. L is the length of the capacitors, right? Students understood? Cylinder understood all? Understood or not, students?
Yes.
And yesterday we have learned about capacitors in series and capacitors in parallel, right? Learned or not? Formula 17. This one 17, I think, right? Yes. Student, in series combination capacitor, right? In series combination, in series combination, 1 by C equivalent is how much, student? 1 by C1 plus 1 by C2 plus 1 by C3. Correct. And in parallel combination, students, all gets added, right? In parallel combination, Cp is equal to C1 plus C2 plus C3, right? Students, yesterday we have learned, yes or no? Students, are you listening all?
Yes,
Then,
sir.
then also I had told you energy stored in a capacitor. What is the formula for energy stored in a capacitor? Subrat? Subrat? What is the formula for energy stored in a capacitor? Half CV square. Yes or no? Q is equal to C by B you put Q square by C. Q is equal to CB you put Q into V. Any formula you can apply, right? You are not remembering anything, nobody. Energy store per unit volume sometime it starts, right? Or energy density, right? Energy stored per unit volume. Energy stored per unit volume or the energy density of the electric field. Energy density of the electric field of a capacitor. That is equal to, students, right? U is equal to half epsilon naught permittivity into E square, right? Right, this formula also. Then electric field between capacitor plates, right? Plate means it is having a area. If it is having a area, it will be having charge density, right? Right, electric field between capacitor plates. Electric field between capacitor plates, that is E is equal to sigma by epsilon naught. Correct? E is equal to sigma by epsilon naught. Understood, students?
Yes, sir.
Are you writing all? In last class before class, right, in the offline mode, I had taught you to remember insertion of a dielectric, right? Capacitor filled with a dielectric. Do you remember K or ER? Remember, na students? So remember K, ER, insertion of a capacitor, insertion of a dielectric. Do you remember or not, Semi? Students? Not right all. To right. Capacitance of a parallel plate capacitor filled with a dielectric constant K. Right? Right. Capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor filled with a dielectric field with a dielectric of dielectric constant K. Right? So that is C, new C will be how much? Dielectric times of initial capacitance. That is epsilon naught A into K. K is ER. Do you remember? K is nothing but relative permittivity. Getting or not? That's why we also say that one is dielectric constant. Amit, Soumya, So Sri, getting or not?
Yes, sir. Yes.
Then next, capacitance of a parallel plate capacitor with a dielectric slab. Means let this is a capacitor, right? This is a capacitor, correct? And in between that there is a dielectric slab. It is not completely filled, that the dielectric slab is having a thickness T, right? Which is less than D. This is D, na? Distance between the two parallel plates, right? So next formula, right? Capacitance of a parallel plate capacitor with dielectric slab of thickness T, which is less than distance between the two plates, right? That formula is equal to how much? C is equal to epsilon naught A divided by D minus T into 1 minus 1 by K, right? It's 23. Next formula. Student, this is if the capacitance of parallel plate capacitor with a conducting slab, this is a dielectric slab, right? This is a dielectric slab. Now understand here, this is a dielectric slab, correct? Whose dielectric constant is given, but it's a conductor. Sometimes it is asking in the question, conducting slab, right? Right, capacitance of a parallel plate capacitor with conducting slab, right? Underline this one, conducting slab. Conducting slab means no dielectric T, that is also less than D. So capacitance is going to be how much? Epsilon naught A by D minus T, correct? That is equal to epsilon naught A by T minus T, correct? Student, let capacitance of a spherical capacitor filled with dielectric, capacitance of a cylindrical capacitor filled with dielectric, right? Simple, where epsilon naught was there you have to multiply the dielectric constant. Getting the students? That means C, capacitance of a spherical capacitor. Capacitance of a spherical capacitor. Capacitance, right? Capacitance of spherical capacitor, right? Filled with dielectric. सिलेंडर में भी देखेंगे, filled with dielectric. That means C is going to be how much? Where 4 pi epsilon naught was there, we have to multiply the ER, that is dielectric constant, right? That is 4 pi epsilon naught K into L. No, dielectric slab is not L, na? That is 4 pi epsilon into K. 4 pi epsilon naught into K, right? That is equal to AB by B minus A. Extra you have to multiply the dielectric constant. If the same thing comes for cylinder, we want to find for a cylindrical capacitor, then in place of near epsilon you have to multiply the dielectric constant K, L divided by, if base is 10, then 2.303 log base 10 B by A. Correct? Understood, students? So these are the basic formulas, right? Just go through these formulas once again and then solve all the numericals. Yes or no? Then I'll be giving assignments on this today. You try to complete it. Okay.